Hey everyone, welcome to the channel. I'm Anurag, and in today's video, we are going to break down question 6 of JEE Advanced 2025. Is it really the toughest problem as reported by many institutes? Let's start investigating. In this problem, we are given a parabola y is equal to x, and we need to find the locus of the midpoint of chord subtending an area 4 by 3 with a parabola. So basically the rough figure is this is the parabola y is equal to x, and this is the chord, and this shaded area a dash should be equal to 4 by 3. Now what is the locus of h comma k, where h comma k is the midpoint. So as you have learned from the previous video that for any quadratic and linear, the area this is basically d root d over 6a square, where d is a discriminant of q dash x, where q dash x is nothing but qx minus lx. Now, so to make this problem more likely to us, I switch the variables y and x so as to obtain the quadratic equation. So I'm doing the transformation y to x, that is taking inverse of the function. And as area is invariable to shifting, there will be no effect. So basically this is a figure, this is the chord, and now what I've done is I'm seeing from here. Rather than seeing from here, if our eye is located from here, I see the curve to be y square is equal to x. But for this eye, I2, he says curve is nothing else, y is equal to x square. So now it will be more convenient to us to solve in the frame of I2, as we could easily solve for a quadratic and a linear expression for their area. So I say let this equation of this line be y is equal to mx plus c. Thereafter our q dash x would be nothing else x square negative linear, that is mx plus c. So our required area would be nothing but d root d over 6a square, which is d to the power 3 over 2 over 6a square. So our required area would be d to the power 3 over 2 upon 6a square. Now substituting for discriminant, which is equal to m square plus 4c. So area, which is equal to 4 by 3, is equal to m square plus 4c to the power 3 over 2 over 6a square, and a is 1. So here we can get that m square plus 4c to the power 3 over 2 comes out to be 8. So m square plus 4c is nothing else but it will come out to be 4. Now we know that for any chord, locus of its midpoint can be related by the equation t is equal to s1. Now t for the equation y is equal to x square we are solving, so we can write it as y plus k by 2 negative h into x is equal to h minus k minus h square. So our equation would be y negative 2hx positive k is equal to 2k negative 2h square. Y negative 2hx equals k minus 2h square. Y yields 2hx plus k minus 2h square. This would yield, comparing it with y is equal to mx plus c, m sub come out to be 2h and c comes out to be k minus 2h square. Now substituting it in this equation 1. So the equation is m square plus 4c is equal to 4. Substituting for variables, 4s square plus 4 k minus 2s square is equal to 4. Minus s square plus k is equal to 1. So s square is nothing but k minus 1. So our equation of curve comes out to be x square is equal to y negative 1. But this is for observer 2. As we have solved in the reference frame of I2, now we need to change x to y for our original equation. So for our answer, we need to take inverse of this function x to y and y to x. So the required curve would be y square is equal to x negative 1. That is, this is our y square is equal to x. Then our curve S, that is locus of midpoint of the chord subtending the area of 4 over 3, is y square over y square is equal to x negative 1. Now, what is asked in our question? The area of the region bounded by these two curves and between x is equal to 1 to x is equal to 4. That is this area. Now, the required answer for this question would be the region of area R is nothing but 2 times integral 1 to 4 x negative root x negative 1 on integration yields 14 over 3 negative 2 root 3. Now, going back to the options, a curve was y square is equal to x negative 1. Substituting for option A, we get y square is equal to 3, so y is equal to plus minus root 3. So the correct answer for this problem will be A and C.